Hi, everyone. My name is Nathalie Moon, and I'm an assistant professor in a teaching stream in the Department of Statistical Sciences. Along with a team of colleagues, I developed a new assessment for my fourth year statistics specialist students, which I'll be telling you about today. Several years ago, my department went through an extensive curriculum mapping process and a detailed list of program learning outcomes was put together. One of the clusters of program learning outcomes centers around effective communication of statistical ideas. While my fourth year statistics students are very well versed in statistical methods and theory, effective communication of these concepts is often a challenge. The assignment I'll be telling you about today specifically targets the development of these skills. For this assignment, students produced short video presentations, so I decided to create a short demonstration myself to give you an idea of the kind of work students might be expected to produce.
For our first scenario, I'll be speaking to Sarah, a 5-year-old child. What's wrong, Sarah? Well, that's a problem. Why was that? That doesn't seem fair at all. Let's see what we could do next time to make it more fair. So let's start by putting all the eggs together, then each person can take one at a time. The number of eggs each person ends up with is the average. So the average is a way to make things equal for everyone. I like averages too, Sarah. Hi, Brenda. What brings you to the statistical consulting service today? Well, what are you trying to do? Okay, so it sounds like you're interested in testing if the average size of fish is different in the two lakes. Is that right? Wonderful. In our next scenario, we'll be speaking about averages with a freshwater biologist who has some questions about her data. I see she's been out in the field measuring fish for her research project and is not sure how to make sense of the data. Well, Brenda, what are you trying to do? I see you caught fish in 2 different lakes and are wondering whether the fish in one lake are bigger than the fish in the other. So it sounds like you're interested in testing if the average size of fish is different in the 2 lakes. Well, the first thing we'll do is calculate the average size of fish in each lake. So to do this, we add up the sizes of the 4 fish we caught, divided by the total number of fish we caught, so that's 4, and we get 14.5. We do the same thing in the other lake, where we add up the sizes of the 3 fish, divide by 3, and get 18.3. So the estimated average size is 14.5 in one lake and 18.3 in the other lake. Now we see these numbers are different, but since we didn't catch all the fish in each lake, the values we got aren't the actual average fish sizes. This sounds like a problem, but it's okay. Statistics can help us make sense of these numbers. We can't practically get a real average fish size for each lake because we'd have to catch and measure all the fish in each lake. So we don't know the true average size, but instead we'll rely upon a sample of fish from each lake to calculate an estimate of fish size in each lake. We know that there's a chance that our sample might be flawed, so we might have caught all the big fish in one lake and all the small fish in the other lake, but we rely on the fact that this is very unlikely. Even if there was no difference in fish sizes across the 2 lakes, it's possible that we could get different estimates from each lake because of the fish we happen to catch in our samples. With the data you've collected, you could do a 2-sample t-test to see if there's evidence that the fish are different sizes on average between the 2 lakes.
In the live session, I'll be sharing more details about the assessment, how it was administered, lessons learned, and advice for those interested in trying it in their own classrooms. I look forward to continuing the conversation there. Bye for now.